Hi there, welcome to Aether on another session on database offerings by Amazon Web Services. In this entire session, we'll discuss AWS Databases managed solution. How are they different from the one managed on your premise? Further, a quick view on what are relational and non-relational databases and what AWS purpose-built database offerings are. We'll discuss AWS relational database offerings like Amazon RDS with lab session and talk about data migration techniques. In detail, we'll discuss Aurora DB and work in the lab session. We'll further move to Amazon Redshift. We'll learn how to handle efficient querying and storage for structured data and discuss Amazon Redshift Architecture and Amazon Redshift Lab session. On AWS non-relational database offerings, we'll talk about Amazon DynamoDB and work on Amazon DynamoDB Lab session and understand performance features. So let's begin with managed database service. See, broadly we can split cloud database into two different deployments. A virtual machine that you manage with your choice of database installed and a fully managed database service. We'll discuss this with reference to RDS and EC2 instances. For virtual machine that you manage with your choice of database and with managed solutions, user no longer have to deal with operational overheads like utilities, hardware maintenance, operating system installation, and rack or stack. Whereas for a managed solution, in addition to above, user doesn't have to deal with operating system maintenance, software installation, maintenance, and software updates. User need not worry about backups, high availability, and failovers. See, for solutions which are managed at your own premise, user has a full control over the entire stack and ability to perform and tune hardware, but it involves quite a lot of tasks. So here AWS offers relational and non-relational database offerings. Before we further move, let's have a quick overview of what are relational and non-relational databases. See, relational databases, as discussed in session 1 of module 2 during an introduction on databases, it is a structured data that can be easily arranged in a tabular format. There are multiple records of different types and each record has a given number of attributes. Thus, it can be stored in a two-dimensional array format where each record is a row and all the attributes for a given record are the columns. Hence, this kind of schema-based data model will allow the user to conveniently store such information as a single record with multiple different typed attributes. Whereas non-relational databases are schema-less designed, the data is completely unstructured or semi-structured. Here application does is simple key value like access. Amazon DynamoDB, Elasticsearch, Neptune are some examples of non-relational stores. Such databases are built to scale out to multiple nodes where the data is replicated on different machines. Database services in AWS refers to a highly manageable and flexible platform that fits your specific application needs. These are fully managed databases services include relational databases with support for 6 commonly used database engine for transactional applications. Non-relational databases for internet scale applications are data warehouse for analytics and in-memory data store for caching and real-time workloads, and a graph database for building applications with highly connected data. Let's begin with relational database Amazon offerings. Amazon RDS is a hosted database service in AWS Cloud. Amazon Relational Database Service is a fully managed SQL database service. Amazon RDS offers various database engines like MySQL, MariaDB, Oracle, SQL Server, PostgreSQL, and Amazon Aurora to help with the database management tasks such as migration, backup recovery, and patching. As said earlier, Amazon RDS provides access to MySQL, Oracle, or a Microsoft SQL Server database engine. This means that the code, application, and tools already in use with existing database can be used with Amazon RDS. Amazon RDS actually automatically patches the database software and backs up your database, storing the backups for a user-defined retention period and enabling point-in-time recovery. Computer resources or storage capacity associated with database instance can be scaled via single API call. Amazon RDS enables replication to enhance availability and reliability for production workloads. For high availability, the Amazon RDS multi-availability zone option tells RDS to run a standby server for high availability. The standby server is in another availability zone. So if the availability zone that the master is in has issues, the standby is still in a good availability zone. The standby is designed to use in a disaster recovery situation. It is not available to be used as a read-only replica. Whenever there is a failover, RDS will then start the database software, the standby, and then AWS updates the RDS DNS hostname underneath. The user doesn't have to update the DNS hostname. Database in case of failure, Amazon RDS for MySQL also makes it possible to scale out beyond the capacity of a single database deployment for read-heavy database workloads. It's important to note that the high availability feature on Amazon RDS is not a scalable solution, and you cannot use a standby replica to serve read traffic. AWS RDS has various advantages, and one of it is scaling service. MySQL RDS offers two levels of scalability features, vertical and horizontal. With AWS RDS, there is no need to keep up with the vendor security and performance patches. There is a very common question which many people ask: why to use Amazon RDS instead of creating a database on EC2? See, there are few benefits of using RDS. Amazon RDS makes database maintenance very easy due to many possibilities. It offers automatic backups, point-in-time recovery, whereas in our own data center, we have to spend much more time on database maintenance and setup. AWS enables user to use database without configuring physical hardware and infrastructure and without installing software. It takes care of security update and use features like directly for snapshots and point-in-time restores. Whether you create a new system or migrate your environment and data to cloud, data residency is a critical element in general, but especially when implementing a long-term infrastructure plan. If your existing database is running on Amazon EC2 or on-premise and you want to take advantage of the managed database services from AWS, one of the challenges is migration of the schema and the data stored inside the database. AWS Migration Service is a managed offering that makes such migrations easier. Using Database Migration Service, customers can migrate data to and from all widely used database platforms such as Oracle, SQL Server, MySQL, Amazon Aurora, and MariaDB. Further, let's understand Amazon RDS offering in the lab session.
Open AWS console. I am already logged in. See, I am in Mumbai region. Now we will go to Database Services and select Relational Database Service, in short RDS. A new dashboard will appear. We are using it for first time, so there is no instance. We have to create a new instance of RDS. First of all, you have to select a RDBMS engine like Aurora, MySQL, SQL Server, Postgre, or Oracle. I will select MySQL engine and hit next. Then you have to select use case. We are going to create a free tier use case. For this there is an option of Dev Test SQL, select it and hit next. Then you have specify database instance. You have to give identifier name. It should be unique database name and password. You can leave other settings as defaults. We are not diving that much deeper. Our motto is to create RDS instance and use it with EC2 instance. Once you complete this form, click on next. On the next page there is advanced settings. Here you have to give VPC for your database and security group for the instance created. I am going to use default VPC and already I have security group. I am going to use it. Now at below, give the database name. You can see port number as well. Rest of the settings are fine to go. So we will leave them as they are and hit Launch DB instance. Now your DB instance is creating. It may take some time. Maybe 10 to 15 minutes to create the instance. We need to make some changes on the security group. Click on the RDS Security Group link. We have to add more rule into the security group. So click on Inbound. Click on Add New Rule and add Prot 3306 to listen. Do as shown in the video. On the IP address you have to provide EC2 instance security group. This is done because if you want to run this database from EC2 instance you have to link it with the instance. When we use IP address for this, then you have used this IP address every time when you are connecting to database. That's why we are using security group. With the initialization of instance database will be also initialized. Till it is creating, let's create an EC2 instance. Go to EC2 services and click on Create Instance. We are creating Amazon Linux AMI. Do the same as shown on your screen. You are already familiar with the EC2 instance creation. Follow the same steps. We will use the same security group that we used in RDS security group inbound rule. So select that security group. We have already an key pair, so we will use DHA same key pair and create the instance. Once our EC2 instance is created, we will configure it to make it usable. Now let's get back to our desktop. I have created a folder and kept my key pair file in it. Now I will open PowerShell or command prompt to log into the EC2 instance. Remember we are using Amazon Linux AMI, so the username of this AMI is EC2 user and we have to SSH it using this username. See on the terminal, I am using SSH EC2 user at the public DNS or public IP address of instance followed by IN key pair file name. As you can see, EC2 instance has been created. Now we will configure our server and install Apache, PHP, and MySQL. Follow the steps shown. Now our server is ready. We have installed Apache, PHP, and MySQL. Next we will check how to use it. So we will go to the public DNS of the instance and see an index page of Apache is shown. Now we will create config.php file to create connection of RDS to the EC2 instance. We have created an config file in var/www/html folder. See the codes of the file. Now save this file and run the config file. You will see output as it has been connected. Our RDS has been successfully configured to the EC2 instance. Now, we will delete all the instances of RDS and EC2. RDS provides you the facility to take snapshot of the database, so that you can again build your database using the snapshot. For now, we don't need to take it, so I will delete it. We will also delete the EC2 instance, because we don't need any more. AWS will charge for it. So it is advised that if you are not using any service, you should terminate it. Our EC2 and RDS instance has been deleted successfully.
Hope you had a great Amazon Relational Database Service lab session. Next, our point of discussion is Amazon Aurora. Amazon Aurora is a relational database engine which is from Amazon Web Services, and it is available through Amazon Relational Database Service. This engine is compatible with MySQL, which means that the code, applications and driver used in database relying on MySQL can be used in Aurora with minimal or no changes. Amazon Relational Database Service manages Aurora databases by handling provisioning, patching, recovery, batchup, and other tasks. A developer can migrate to and from MySQL databases by using the MySQL dump and MySQL import utilities, or by using Aurora DB snapshot migration feature. Basically, Aurora stores a minimum of 10 GB and scales automatically to a maximum of 64 TB. The service divides the volume of a database into 10 GB chunks, which are spread across different disks. Each chunk is replicated 6 ways across 3 availability zones. If a data in one availability zone fails, Aurora attempts to recover data from another availability zone. Aurora is also a self-healing, meaning it performs automatic error scans of data blocks and disks. A developer can scale up resources allocated to a database instance and improve availability through Amazon Aurora App Replicas, which share the same storage as the Elastic Compute Cloud instance. An Amazon Aurora replica can be promoted to a primary instance without any data loss, which helps with the fault tolerance if the primary instance fails. For security, Amazon Aurora encrypts data in transit through the AWS Key Management Service. Automated backup snapshots data at rest in the underlying storage, and replicas within the same cluster are also encrypted. Additionally, Aurora databases instances are created within Amazon VPC, allowing user to isolate a database within their network for more security. See, if a developer has made an Aurora replica, the service automatically fails over within 1 minute, and it takes about 15 minutes to fail over without a replica. Amazon is a pay-per-use service in which a user pay per instance. Customer can opt for either on-demand or reserve pricing. Amazon also bills customers for any storage Aurora uses in GB per month increments and according to input-output rate. So this was about Amazon Aurora. Let's move to the lab session to understand it better.
Let's do the lab session on Aurora DB in RDS. This DB is created by Amazon, so it can't be used outside. It is compatible with MySQL and Postgre. I am logged into the AWS console and click on the RDS service under Databases. It is same as RDS, but it is very scalable and fast compared to MySQL database. Now you have RDS dashboard, click on Get Started and select MySQL engine. In the use case, select Production Aurora instance and hit on Next. In the next dashboard you have to provide information about the instance. In setting you have to give instance name, master username and password, as you did in RDS Lab. Rest of the default settings are fine. We will go with it and hit Next. Now moving to configure advanced setting, you have to provide VPC and subnet information. I will use default VPC and default subnet. Create a new security group for it. The default settings are good enough to go. We are focusing on System Administrator course, and for this course this much of information is good. You must have knowledge about these things. Moving to database setting, you have to give cluster name, as this cluster name will be used to create DNS for your database instance. Next you have to provide database name. The rest of the settings are fine. Once done your setting, hit on Launch DB instance. Your instance is creating. You can view it. It may take some time, around 10 to 15 minutes. Here you can see two instances are creating, one is replica in different AZ. We have to wait until it is not created. As you can see, the status is showing available on the instance dashboard. This means that you can use it now. We don't have to do much in this. We will create a replica of this instance. This replica is used when the original instance is not available. Let's create it. Go to Instance Action and hit on Create Replica option as shown. A new page will appear. You have to provide the details as you did when creating the instance. On the failover you have to select the tier structure. This is used to define sequence of working. For now I am choosing 2-tier, that means if original stops it will be used next. Then hit on Create Aurora Replica. It is creating. It will also take some time to create. Till it is creating you can see the dashboard of the two instances running. You will notice that the cluster name that you provided while creating the instance is used in the DNS. You have other options also on instance action. You can create replica, failover, stop instance, reboot and delete. This was all in this lab. Remember, when you are not using Aurora instance, you must delete it as it charges for the active instance. So we will also delete all the instances created. First of all, we will delete the replica instance, then the Aurora original instance. It can also take little time to perform the task. Now all the instances has been deleted. Never leave any instance running if it is not in use, because this can affect your budget.
Hope you all had a great lab session of Amazon Aurora. Our next topic of discussion is Amazon Redshift. Amazon Redshift in general is a fully managed data warehouse service that can scale from just 100 gigabytes to petabytes or more. It operates and scales a clustered relational database engine which is suitable for complex analytic queries over a large data set and is specially suitable for OLAP style workloads such as data warehouse, analytics and big data and ELT. Redshift is designed to connect SQL based clients and business intelligence tools for analytic workloads. In order to set up, first we need to create a data warehouse and to launch a set of nodes which are called as Amazon Redshift clusters. After you provision your clusters, you can upload your data set and then perform data analysis queries. Regardless of the size of the data set, Amazon Redshift offers fast query performance using the same SQL based tools and business intelligence application that you use today. Data warehousing is used to extract data in periodic stages or as they are generated, making it more efficient and simpler to process queries over data that actually came from different sources. The raw data is turned into high quality information to meet all enterprise reporting requirements and also for all levels of users. See, basically Amazon Redshift is a combination of two important technologies. First, it's column-oriented structure, and second, it uses massively parallel processing. Column-oriented DBMS stores data as section of columns of data instead of as rows, as you would have more find in conventional RDBMSs. Column-oriented databases are particularly useful for data warehouses, analytics and big data application as they resolve queries very quickly. Redshift uses columnar storage technology in order to improve input-output efficiency and parallelized queries across multiple nodes and provide fast query performance. The service also offers custom ODBC and JDBC drivers which a developer can easily download it from Connect Client tab of console. It also allows you to access the wide range of familiar SQL clients. Secondly, Amazon Redshift is built on data warehouse technology, MPP, massive parallel processing. Here, multiple compute nodes handle all query processing, leading up to the final result aggregation, each node executing the same compiled query segments on portions of the entire data. Amazon Redshift distributes the rows of a table to the compute node so that the data can be processed in parallel. By selecting an appropriate distribution key for each table, user can optimize the distribution of data to balance the workload and minimize movement of data from node to node. Amazon Redshift has many benefits. Amazon Redshift uses efficient techniques and a variety of innovations in order to obtain a very high level of query performance on large amount of data sets, ranging from 100 gigabytes to a petabyte or more. Redshift has massive parallel processing architecture, distributing SQL operations and parallelizing techniques to take full advantage of all available resources. It is highly scalable. The Amazon Redshift can be easily scaled in just few clicks through the AWS Management Console or by a simple API call. If your organization requires a change, you can easily add or remove a number of nodes in your cloud data warehouse. The scaling property in traditional data warehousing is not so easy and is very complex. And if you want to change your data warehousing structure, dense storage nodes allow you to handle very large data warehouse structure using HDD. HDD is hard disk drives. Amazon Redshift is fully managed. Automatic data backups, upgrades and patches are services provided by Redshift that helps you to focus on your data and business. It gets started in minutes. Using simple API calls or AWS Management Console, you can create a cluster, define its size, security profile, and underlying node type. The complete data warehouse for your organization will be up and running in no time. Amazon Redshift provides an excellent solution for your data warehousing needs to create your cloud cluster, manage, scale, and accessing insights. Let's further focus on its architect. Redshift works in a cluster formation. A typical Redshift cluster has 2 or more compute nodes which are coordinated through a leader node. All client applications communicate with the cluster through a leader node. Now, what is this leader node? Leader node in a Redshift cluster manages all external internal communication and is responsible for preparing query execution plans. Once the query execution plan is ready, the leader node distributes query execution code on the compute nodes and assigns slices of data to each compute node for computation of results. Leader node distributes query load to compute node only when the query involves accessing data stored on compute nodes. Otherwise, the query is executed on the leader node itself. Compute nodes here play an important role as they are responsible for actual execution of queries and have data stored with them. They actually execute queries and return intermediate results to the leader node, which further aggregates the results. So there are 2 types of compute nodes which are available with the Redshift architect. One is dense storage, another one is dense compute. Now this dense storage node allows you to create large data warehouses using hard disk drives for a low price point, whereas dense compute node allow you to create high performance data warehouses using solid state drives. So let's understand in detail how the responsibilities are divided among leader and compute nodes. See, node slices. A compute node basically consists of slices. Here each slice has a portion of compute node's memory and disk assigned to it, where it performs query operation, whereas the leader node is responsible for assigning a query, code and data to a slice for execution. Slice once assigned query load work in parallel to generate query result. Further, data is distributed among the slices on the basis of distribution style and distribution key of a particular table. An even distribution of data enables Redshift to assign workload evenly to slices and maximizes the benefit of parallel processing. Number of slices per computer node is decided on the basis of the type of node. Since we had discussed that our Redshift architect allows it to use massively parallel processing for fast processing even for the most complex queries and huge amount of data. So multiple compute nodes execute the same query code on portions of data to maximize parallel processing. Data in Redshift is stored in columnar fashion, which drastically reduces the input-output on disk. Columnar storage reduces the number of disk input-output requests and minimizes the amount of data loaded into the memory to execute a query. Reduction in I/O speeds up query execution and loading. Less data means Redshift can perform more in memory processing. Redshift uses sort keys to sort columns and filter out chunks of data while executing queries. Another important is data compression is one of the most important factor in ensuring query performance. It reduces storage footprint and enables loading of large amount of data in the memory. Owing to columnar data storage, Redshift can use adaptive compression encoding depending on column data type. Redshift has a query optimizer generate query plans that are MPP aware and takes advantage of columnar data storage. Query optimizer uses analyzed information about the tables to generate efficient query plans for execution. So this was the understanding how the responsibilities were divided among leaders and compute nodes. Now let's further move to the lab session on Amazon Redshift. Let's see how do we set up cluster nodes, etc. Moving toward the lab session.
In this session we will discuss about Amazon Redshift under database services. As you know, Redshift service is used for analytics or simply you can OLAP. Let's start it. Hit on the Redshift service. A new dashboard will appear. Here you have to create an instance or cluster for the Redshift service. Hit on Create Cluster. On the next page, you have to give an identifier for your cluster. So I gave it name as Aether cluster. Next tab is about database. Give name to your database. I gave it Aether. Then you can see a port number is already defined there. Redshift works on this port. Then you have to give password for your database. Make sure password should be not less than 8 characters and it should be alphanumeric and there must be one letter in uppercase. Once completed the form, hit on Continue button. The next tab is about node configuration. You can link your purchased nodes ASLO to the Redshift. We don't have any node, so we will go with the default settings of it. You can simply click on Continue. For now, memory is fine, instance is fine and all the default settings are fine. So hit on Next. Next is about additional configuration. Here you can define encryption type. Provide VPC group and subnet. I will use default VPC and subnet. You can give permission of accessing it in public or not. I will give it yes. Next is if you want to give it public IP, if you select yes you can get the list of public IPs associated with your account. For now I will choose no. Then if you want to enhance the VPC routing then you can choose yes, for now no is okay. Next is select your AZ, I will give it no preference. Then if you want to create an alarm in the cloud front, say no. Then hit on Continue. Now you can see review page on the screen. Here you can have look once to the settings that you wanted to create. You can see database, security, and other stuffs. Down there you can see an alert box that is saying that if you create the cluster you will be charged for it. Redshift does not comes under the free tier services. You will be charged for creating and using Redshift cluster. Let's create it, and remember you must delete all the cluster instances if you are not using it. Let's hit on the launch cluster. Our cluster is being creating. You can see it on the dashboard. Let's click on the view instance. Cluster to be available for the use will be available after 10 to 15 minutes. It takes that much time in creating the instance. Let's leave it and we'll be back once it is available. Now our Redshift cluster is available. Its health is also good, it's showing healthy. You can see the details on the dashboard. Basically Redshift database is used to analyze the data. We need to provide the tables or data to the cluster of Redshift and it create analysis on the basis of data inserted. You can use this Redshift to your application by using JDBC or ODBC driver tools. Let's see the details of the instance created. You can see the DNS of the cluster created and other settings that we provided. We will see all the options with the Redshift cluster but not make any change to it as we don't have database right now and it is also the Beyond the Syllabus System Administrator course. So watch the tabs carefully. You can notice that every tab describes itself. You can read it and understand it what are these tabs and why it is used. Let's have a look one by one. On the Redshift Client Connect tab you can see the option of downloading the JDBC and ODBC drivers. You can also get the URL of these drivers. You can use it with your EC2 instance. And also can have the configuration documentation link. So you can easily connect your instance with Redshift database. Now let's click on our instance and see what can we do with it. So from the dashboard I will hit on cluster. It will show another dashboard where you can see the different actions to be performed with this instance. Now we are at the instance dashboard. We will just checking in out this option so that you become familiar with it. Whenever you need to use it, it should give that you have been here. So let's see each tabs one by one. Once gone through the tabs, we will delete the instance. From the cluster button you can see the delete option and we will delete this cluster. If we don't delete it, AWS will charge on the basis of instance available hourly. Better is to delete it. Deletion will also take some time. Instance has been deleted now.
So this was all about our lab session on Amazon Redshift. Hope you all had a great lab session. Our next topic of discussion is DynamoDB. It is a fast, fully managed NoSQL database service that makes it simple and cost-effective to store and retrieve any amount of data and serve any level of request traffic. Its guaranteed throughput and single-digit millisecond latency makes it great fit for gaming, ad tech, mobile and many other applications. All data here is stored in solid-state drives which provides high input-output performance and can more efficiently handle high-scale requests. An AWS user interacts with the service by using AWS Management Console or DynamoDB API. Here, a user stores data in DynamoDB table, then interacts with it via GET and PUT queries, which are read and write operations respectively. DynamoDB supports basic CRUD operations and conditional operations. Each DynamoDB query is executed by a primary key identifier by the user which uniquely identifies each of the item. See, for high availability, DynamoDB enforces replication across 3 availability zones. So a user actually can opt for cross-region replication, which creates a backup copy of a DynamoDB table in one or more global geographic locations. Here, the DynamoDB Scan API provides 2 consistency options when reading DynamoDB data. Eventually consistent reads and strongly consistent reads. Here, the former, which is AWS default setting, maximizes throughput at the potential expense of not having a read reflect the latest write or update. The latter reflects all writes and updates. There are no DynamoDB limits on data storage per user nor a maximum throughput per table. See, DynamoDB offers a fine-grained access control (FGAC) for an administrator to protect data in a table. The admin or the table owner can specify who can access which item or attributes in a table and what action that person can perform. Fine-grained access control is based on AWS Identity and Access Management Service, which we will talk about later in our upcoming sessions, which manages credentials and permissions. As with other AWS products, the cloud provider recommends a policy of least privilege when granting access to items and attributes. Here, an admin can view usage metrics for DynamoDB with Amazon CloudWatch. Other important feature which DynamoDB has: DynamoDB triggers features integrates with AWS Lambda to allow a developer to code action based on updates to items in a DynamoDB table, such as sending a notification or connecting a table to another data source. So this was all about DynamoDB and the features of DynamoDB. Now let's understand via lab. Moving towards lab.
We will do DynamoDB Lab. For this you have to log into your AWS account. I am already in, and select region. As you can see, I am in Mumbai region. Now go to Services drop down and go to Databases Services. There you have to select DynamoDB service, or you can also search in the search box. Hit on it. A new dashboard will appear. I am using this for the first time, so there is no instance running. We will create it. Now let's create table in DynamoDB. Hit on Create Table button. Now you have to provide table name. I gave it name as student. Next column is for the primary key. I gave it name as student ID and its data type as number. You can select the data type from the drop-down menu. Rest of the settings are fine for Go. DynamoDB is a NoSQL database where you can create columns on fly. Now I will hit on Create Table. Table is being creating. It can take little time to create table. Now our table is ready. You can see the overview of it. Next we will add some items to the table. So let's move to the items option next to overview. Here you can see the table name. Now we will add items or records to the table. Hit on Create Item. You can see the first column is created. You have to give value for it. Now click on plus icon. You will get 3 options: append, insert, and remove. You can append if you want to add new column after student ID, then hit on append. If you want to insert before student ID, hit on insert, and if you want to remove column, then hit on remove. For now we will append a new column called student name and its data type as string, then give value to it. Hit on save. You can see the value that you added is shown on the table. Now let's create another item with a new field. Hit on Create Item and append student name and course. Give value to it and hit on save. Now you have 2 records, one with 2 columns and other is with 3 columns. You can slow search items on the basis of these fields. This database has no relation with the columns like RDBMS tables. So there is no SQL query for it. It works on indexing. Now let's see metrics. Here you can check the read and write capacity of the tables through graphs. With the help of matrices you can manage your DynamoDB table. We don't have to do anything to it. This is just analysis of your table. Next tab is about setting alarms for your records. You can manage alarms for the record. It is stored on the CloudWatch service of the AWS. Here also we don't need to do much. For Solution Architect course you don't have to deep dive into it. You must be familiar with the DynamoDB. Next tab is about capacity. In this you can manage your read and write capacity. DynamoDB charges for it. For writing in DynamoDB is costlier, but read from it is very cheap. So you can make change in read and write capacity. This tab will also give you the estimated price based on the capacity you opted for. You can change it and save it. Remember, if you are not using DynamoDB isn't ANS, you must delete it as Amazon charges for the active instances. Deleting an instance is very easy. You have to select your table and delete it. It will take little time to delete. Now our instance is deleted.
That's all in this session on databases. Hope you had a great session. Stay tuned and join us in our next session on AWS high-level building blocks and cross-service features. Next session will be an overview of all these services by Amazon Web Services. Thank you.